Namaskaram. Last lecture we have seen RC coupled amplifier in which their flat response is achieved in between 50 Hz to 20 kilohertz only. Below and above the 20 kilohertz there is a high frequency roll off. Okay, but in case of a direct coupled amplifier, it is also called a DC amplifier. Why a DC amplifier or direct coupled amplifier? The name suggests itself the circuit configuration or circuit construction. Here the output of first stage of a amplifier, that is the collector terminal, is directly attached to the base, that is the input of next stage of amplification. There is no a coupling element used here. That is, as we seen in a RC amplifier, there is RC, here is also RC and CC. These three elements make a coupling network, particularly CC, that is called coupling capacitor. But here is no use of a capacitor to connect the input of first stage of amplification to the second stage. That's why it is called direct coupled amplifier, or also called a DC amplifier, which is especially used for very low frequency, that is the frequency below 10 Hz, or the signal which are weak having a frequency ranges 10 Hz, including direct current or zero frequencies. It may be noted that the capacitor, inductor and transformer cannot be used as a coupling network at very low frequencies because the electrical size of these devices at low frequencies become very large. This figure particularly as shown, it is a two-stage direct coupled transistor amplifier. As such two-stage, it means there are the two active elements Q1 and Q2 which are directly coupled. That is, collector of Q1 is directly coupled with base of Q2. The output of first stage is directly connected to the base of the next transistor. Moreover, there are no input or output coupling capacitors. The operation of these circuits here is, the signal to be amplified is applied directly at the input of first stage. Here shown, the Vin is applied to the base of Q1. Due to the transistor action, it appears in the amplified form across the collector resistor or transistor Q1. At this end, we get output, that is collector terminal. The voltage then drives the base of second stage, that is Q2, and the amplified output across the collector or transistor of Q2 is driven as like this V0. Okay, I just go for the frequency response, rotate it. Yes, this graph is a frequency response of a direct coupled amplifier. This figure shows the frequency versus voltage gain. As a function of a frequency, there is a voltage gain. Figure shows the frequency response, that is a graph of dB voltage gain versus frequency in Hertz of a direct coupled amplifier. It is evident from this graph the gain is uniform up to a certain frequency denoted by F2. Beyond this frequency, there is high frequency roll off. The gain roll off at higher frequencies due to increased emitter diode capacitance and stray wiring capacitance. But the most interesting thing, flat response we get initial stages below this F2 or critical frequencies. Now see the advantages. In advantages, there are listed as, the circuit arrangement is very simple because it uses minimum number of resistances. Yes, of course, there is no collector resistances and CC and capacitors, all this. The circuit cost is low of the absence of expensive coupling device. As there is no coupling device, so coupling the cost for coupling network is becomes zero. It can amplify very low frequency signal down to zero frequency signal. It amplifies very weak frequency signal, start from the zero. Disadvantages: it cannot amplify high frequency signal as shown in the figure here. For higher frequency above the F2 there is a higher roll off. It has a poor temperature stability. Because of this, its Q point shifts. In multi-stage direct coupled amplifier, the Q point means operation point or QCN point, it shifted and amplified in succeeding stages. Thus, a small DC shift in the first stage can causes the final stage to be either saturated or cut off. Or we know whenever transistor goes in saturated mode, it behaves as like an on switch, and if it is gone in cut off mode, then it is act as an off switch. We have to behave a transistor in a as an amplifier, so we have to put the input junction in forward bias and output junction in reverse bias. This is achieved by setting the Q point in a particular active region. That's why we need a biasing and accessories. All integrated circuit amplifiers are direct coupled. Because of the difficulty of fabricating large integrated capacitors, it led to special problem in their design. Fabrication म्हणजे डिझाईन, त्यांचं डिझाईन करत असताना आपल्याला असा प्रॉब्लेम येतो. Applications: analog computation, power supply regulator, bioelectric measurements, and linear integrated circuit, that is linear ICs. Okay, that's it about direct coupled amplifier. We continue our discussion about oscillator with the term oscillator. Oscillator, the electronic device which generate oscillations. If we are talking as a comparison point between what amplifier and an oscillator, amplifier amplifies and gives a signal output if there is a signal input only, and with help of, if you apply the weak signal as an input signal, then due to the DC power sources, that is a VCC applied over here, amplifier get the power from this DC sources, and we get higher magnitude or magnitude boosted output signal. But in case of oscillator, there is no need of an input signal, only the DC bias is applied and it itself generate a signal output. It means an oscillator is said to be an amplifier without applying input signal. An oscillator is analogous to the amplifier. If we remove or if we not apply input signal, then also we get output signal with help of a DC power input. Okay, now if you're talking about the classification of an oscillator, then a broad classification is sinusoidal or harmonic oscillator. The oscillator which produces the output having sine waveform is called sinusoidal or harmonic oscillators. Such oscillation can be provided the frequency range 20 Hz to 1 GHz. Gigahertz 10 to the power 12 Hz. And next category, non-sinusoidal or relaxation oscillator. The oscillator obvious which having the output square, rectangular, sawtooth, which is not sinusoidal in nature, are called non-sinusoidal or relaxation oscillator. The frequency ranges is nearly 0 to 20 megahertz. Megahertz 10 to the power plus 6 hertz. Okay, rather category, we are only interested for the sinusoidal one. Okay, now we will see our the Barkhausen criteria. First of all, the Barkhausen criteria, and then we will see the types of oscillators. Okay, here is the Barkhausen criteria.